this video is chemical names and formulas. The essential questions are why do atoms gain a charge, and how can you predict what the charge will be by looking at the periodic table. So, to form an ion is going to have a positive or a negative charge depending on if it's gaining or losing electrons. Okay, so metals will lose electrons and they form a positively charged ion. Because they're losing electrons, they're losing negatives. So they end up being positive. This is called a cation, not a caution, but a cation. Okay, this process is called oxidation, and it follows the octet rule. Octet rule, you can think of oct goes with the number 8, and they all want to have 8 valence electrons, which would mean they're going to be an electron configuration, a S2p6 configuration. Atoms will gain or lose electrons in order to have the same number of electrons as a noble gas, because that's what a noble gas has, is 8 valence electrons. So we'll go through the groups. The first group is the alkali metals. An atom is going to have a neutral charge. So we'll use sodium for an example, and it has 11 protons and 11 electrons. Okay, and so its electron configuration is 1s2, 2s2, 2p6, 3s1. So that 3s1 is keeping it from having that configuration of a noble gas. So it will become an ion, and so now it's not going to be neutral anymore. It's going to keep its 11 protons. It has to keep that in order to remain sodium, but it's going to lose an electron, so it will only have 10. Now, because it only has 10 electrons, it's going to have a 1s2, 2s2, 2p6 electron configuration, and so that gives us that s2p6 configuration, which gives us 8 valence electrons. So it gets rid of that 3s1, and it makes it like neon, like a noble gas, which is what it wants to be stable. So all the alkali metals will follow this pattern. They'll lose 1 electron to form an ion with a 1+ charge. So lithium +1, sodium +1, potassium +1, rubidium +1, and you don't have to write the 1, you can just write the plus. Okay, now for group 2, the alkaline earth metals. So we're going to look at calcium for an example, and remember atoms are neutral, so calcium has 20 protons and 20 electrons. Okay, and it has a 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 electron configuration. So we don't like that 4s2 because we want to end in s2p6. Okay, so the ion is going to lose 2 electrons. It has to keep the 20 protons to remain calcium. And so now it's got that 3s2, 3p6 configuration, which makes it like a noble gas, like argon. So all the group 2A metals are going to lose 2 electrons to form an ion, and they'll have a +2 charge. So like magnesium +2. Now you do have to include the number at this point because it's not just 1. Calcium +2, barium +2. Okay, the group 3A metals, so we're going to skip the shorter section in the periodic table and go to the next tall column, which starts with aluminum and boron. Okay, and these are going to follow the same pattern. They will all lose 3 electrons to form an ion with a +3 charge. So aluminum +3, gallium +3, indium +3, and so on. Nonmetals are going to gain electrons to form negatively charged ions called anions. Okay, so that's going to include hydrogen at times. It can be a +1, but it's also going to be an anion sometimes. And then my nonmetals are all over here on the right. My noble gases are nonmetals, but they do not form ions because they already have their 8 valence electrons. So this process is called reduction when they gain electrons. We'll look at the halogens first, which is almost all the way to the right. It's that group 7A, which is one back from the noble gases. We'll use fluorine as an example, so the atom will be neutral, so it's going to have 9 protons and 9 electrons, and it has a 1s2, 2s2, 2p5 electron configuration scale. So it is 1 electron away. It needs 1 more. So the ion is going to snag an electron from somebody else. So now it has 9 protons to remain fluorine, but it has 10 electrons. So it creates that 1s2, 2s2, 2p6. So we have that s2p6 electron configuration that makes it like a noble gas. This one would be like neon. So all the group 7A elements will gain 1 electron to form an ion with a -1 charge. Fluorine, chlorine, bromine, and again, when it's just a 1, you can just put the positive or negative sign on the ion. Okay, group 6A, this is the one that starts off with oxygen. We'll use sulfur as an example. The atom will be neutral with 16 protons and 16 electrons. So our electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. We want an s2p6, not an s2p4 electron configuration. So the ion will gain 2 extra electrons, so we have 18. And that creates that 3s2, 3p6 configuration that we would like, which makes it like argon, like a noble gas. So all the group 6a atoms will gain 2 electrons to form an ion with a -2 charge. Oxygen -2, sulfur -2, selenium -2, and so on. Okay, the group 5a, we're working backwards, so we've gone gaining 1, gaining 2, so these will gain 3, and they will have a -3 charge. So nitrogen 3-, phosphorus, arsenic, and so on. Okay, our transition metals, we are looking at that shorter section in the middle. These have various oxidation numbers or charges. And a couple of them stay the same, some of them change. You're going to have to memorize 3 here. First of all, hydrogen is a -1 when it's combined with a metal. So it can be a +1 when it combines with a non-metal, or it can be a -1 when it's combined with a metal. Zinc will always be +2, silver will always be +1, and cadmium will always be +2. So in short, you need to memorize that this first column is a +1, this second column is a +2, the third tall column is a +3, and then we're going to skip carbon and come back to that. Then we have -3, -2, -1, and if you look, hydrogen is in both columns just on this example. It's not obviously there usually. And then you will have no ions out of the noble gases. They do not form ions. They remain neutral. Okay, so carbon's group can be a +4 or -4. It kind of depends on what it's combining with. And then we have our special cases. So silver's a +1, zinc's a +2, and cadmium's a +2 also. So you will need to know those and be quick with those. It will help you a lot as we start to make formulas. Okay, so the transition metals we said can change sometimes, and when we're naming, they have a stock name and a classical name. We will mostly use the stock name, but you're going to have to recognize the classical name too, and it will tell you what charge it has. So if we look at copper on our first one, it has a +1 charge there. And that's a copper, and we put a Roman numeral 1 behind it. Okay, that tells us that it's copper +1. The classical name, you take the Latin part of the word, which is cup, and then you add OUS, so cuprous. Okay, and so that would say like cuprous oxide or cuprous sulfide, and that would tell us that it's a +1 charge. Okay, copper +2 is just going to be copper with Roman numerals 2, and it's going to end in IC, so cupric. So OUS means the lower number that it's possible, and IC, if it ends in IC, it means the higher number that's possible. So copper can only be +1 or +2. So OUS would mean the lower, which is +1, and IC would mean the higher, which is +2. Okay, there's an error on this mercury one. It should be just a +1. Okay, so ignore those 2's. So this would be mercury 1, or mercurous. It's still following that OUS rule. And then the second one says mercury +2, so that's mercury 2, and that's going to be mercuric. Okay, Fe is iron, so it's going to be iron 2, and the Latin word for iron is fer, so we're going to have ferrous. Okay, and then Fe +3 is iron 3, and we'll see ferric. Okay, Cr is chromium, so we have chromium 2, and that's chromis. And then Cr +3 is chromium 3, or chromic. Okay, so again, they can either use the stock name or the classical name. You need to be able to recognize both. Finally, chromium 6+. We're not going to have a classical name for that one. We're just going to use the stock name, which would be chromium 6. Couple more. We have cobalt +2. So it's going to be cobalt 2 or cobaltus. And then cobalt +3 would be cobalt 3 or cobaltic. Sn is 10. So we have 10-2 or stannous. Stan is the Latin root for 10, so stannous. And then we have 10-4 or stannic. Finally, we have Pb, which is lead, so we can have lead 2, which is plumbus. Plumb is the root for lead in Latin. And then lead 4, which is plumbic.